My name is Spencer Peak. I did my instructional unit on geometry. My focus was on triangles. Some of the things that my unit covered and my exam are over is Pythagorean Theorem, finding the missing length or missing side of a triangle, trig functions like sine and cosine, and using those to find the missing side of a triangle, and then also similarity and congruence of triangles. For my exam, there are several questions that include Pythagorean Theorem. One of my lessons was totally focused on this, and it's a very important skill. So I'm going to spend some time reviewing the Pythagorean Theorem for the exam, and just reviewing so you have a better understanding of what it is. The Pythagorean Theorem is a squared plus b squared equals c squared. And the Pythagorean Theorem is only able to be applied to triangles that are right triangles, or in other words, a triangle that has one angle that measures 90 degrees. So for example, if this is a right triangle, the right angle, or the 90-degree angle, is going to have two sides that come out from that angle. Those two sides are going to be A and B, and it doesn't matter which one's which. So we'll call this side A and this side B. C, on the other hand, is always going to be your hypotenuse. Your hypotenuse is the longest side of the triangle, and it's also always going to be the side that is across from the 90-degree angle. So this right here is going to be our C, because it's across from the 90-degree angle. It's also our longest side. So anytime you have a right triangle and you have two of these sides, you can plug it into this formula and find the missing side, just using some basic algebra to clean it up. So we're going to do a couple example problems, and then after that we'll look at some word problems like you might see on your exam. The first basic example we'll use is a right triangle with the right angle right there, and our hypotenuse is 17 and this leg is 15. We want to know this length right here. So when we look at it right here, we have only one of our legs coming up from that 90-degree angle. So we'll call this side A and this side B. We don't know what A is, so we'll leave A as our variable. Then we do have a B, so plus 15 squared equals C squared, or our hypotenuse squared, 17 squared. So we can just plug these into our calculator. 15 squared is, I have A squared plus 15 squared is 225 equals 17 squared, which is 289. And so now that we have this, we have one variable. It's just some basic algebra. Just subtract 225 from both sides. And so that gives us A squared equals 64. Take the square root to cancel the squared of both sides. And that gives us A equals 8. So this missing side right here is 8. We'll look at one more example before we move on to the word problems. Let's say we have a right triangle where this is equal to 13, this side is equal to 5, and we want to know this side. So first off, we're going to look for the two legs coming out of the 90-degree angle. For the first one, we don't know what it is, so that's going to be our variable. So we're going to leave as A squared plus, we do have a B for the second leg, so it's going to be 5 squared equals the hypotenuse squared, or c squared, which is 13 squared. So then we're just going to work out these exponents, and we're going to get a squared plus 5 squared, 25, equals 13 squared, 169. Subtract 25 from both sides. A squared equals 144. Take the square root to cancel the squared, both sides. A equals 12. So this side right here equals 12. So one of the reasons that the Pythagorean Theorem is so important is it has so many applications in everyday life. You're going to use it a lot as you get into more advanced maths after basic high school geometry, but there's so many everyday problems in life that you can just figure out if you just understand this basic formula and how it can be applied. So we're going to look at some of these real life problems or word problems like you might see on your exam, and work out a couple examples of those. So let's say you have a baseball field. And we have home plate down here, first base right here, second base, and third base. And it's a perfect square because the distance from each base to the next is 90 feet. So we have 90 feet, 90 feet, 90 feet, and 90 feet. So let's say we want to know the distance from home plate straight to second base. So we want to know this distance right here. So we can actually use the Pythagorean theorem to solve that, because if you take away this side right here, it's easier to see that we actually have a right triangle, because when you run to first, it's a 90-degree turn to go to second with two variables, and we're looking for the third. So we have a right triangle. So we're just going to use the Pythagorean theorem and plug these in. Here's our 90-degree angle. So we have our two sides coming out from there. So we have our A and B. So it's going to be 90 squared plus our B is also 90 squared equals our hypotenuse squared, which is what we're looking for, our distance from home plate to second base. So our 90 squared is going to be equal to 8,100 plus 8,100 equals c squared. And so when you add those two together, it's going to be 16,200 equals c squared. And then to cancel out the squared, you're going to take the square root of both sides, and that's going to leave us with c equals the square root of 16,200, which is 127, and a lot of decimal places, we'll just round it to the nearest hundredth, 0.27, and that's going to be feet. So our distance from home plate directly to second base is going to be 127.27 feet. So we'll solve one more word problem just to help you get ready for the exam, because there will be one on there, if not more. Let's say we have a jogger, and our jogger runs 8 miles north. Then, after running 8 miles north, our jogger turns and runs 5 miles west. And let's say our jogger wants to know how far it's going to be to jog directly from where he is now back to his starting point if he wants to go in a straight line. So we want to know this distance right here. So we know from north to west that's going to be a perfect 90-degree turn. So we have a 90-degree angle right here. So this leaves us with a squared plus b squared equals c squared. We have a right triangle with two sides looking for the third. The distance from where the jogger is after running 8 miles north and 5 miles west. We want to know the distance back to his starting point. So our right angles here, we have the two sides connected to that 90-degree angle, so we have our A and B. So we'll call 5 our A, so we have 5 squared plus 8 squared equals, we don't know this, we don't know our hypotenuse, so we'll leave that as our variable, c squared. Work out the exponents, 25 plus 8 squared is 64 equals c squared. Add those together, that's going to be 89 equals c squared. We want to cancel that squared, so take the square root of both sides, and that's going to leave us with c equals the square root of 89, which is 9 point, once again we have a bunch of decimal places, we'll just round to the nearest hundredth, 4.3, and that will be miles. So if the jogger wants to go directly from this point back to where he started, it's going to be 9.43 miles. So as you can see, application of this skill has almost unlimited uses in everyday life, and it's really useful and really important. But like I said, if you pay attention to this review, if you understood all 4 of those examples, then you should not have any problem with solving any of the Pythagorean theorem problems on the test.